Good day, everyone, and welcome to the 19th edition of the group exhibit Hydrogen and Fuel Cell here at the HANNOVER MESSE 2013. I invite you to come and have a seat. Drinks are on the house. My name is Marie-Hélène Nieb, and I have the great pleasure today to discuss development of new membrane material at ITM Power. Please help me welcome the CTO of ITM Power, Dr. Simon Bourne. Thank you for joining us.
Thank you.
I want to apologize right away for my voice. I kind of lost it, so I'll try to do my best that you can still hear me. Let's just start by, what is ITM Power core competences?
Well, ITM Power is an electrolyzer company, and we have particular expertise in PEM electrolysis. And what we do is we integrate full systems, and the main markets that we're interested in are clean fuel, energy storage, and renewable heat.
And you've done quite a bit of development work on your PEM membranes. Could you tell us about this development and how good we are at, or where we are at?
Sure. Well, one of the core functions of ITM in the early years was development of our own membrane material. And the material that we have is appropriate to both electrolyzers and fuel cells. And so we had to make a decision early on in the company whether we were going to focus our efforts on electrolyzer applications or fuel cell applications. And our focus has been on electrolysis, but there's always been a small part of our development looking at fuel cells as well. And I've been with the company for just over 11 years now, and the vast majority of that time has been spent working on the core technology of the membranes, the catalysts, and the cell architecture.
And could you tell us why you think ITM decided to concentrate on electrolysis rather than the FC?
Sure. Well, we decided to focus on electrolysis because we thought the market was bigger and easier to access. The advent of the fuel cell electric vehicles is making a slight change. It's driving both more electrolyzers and fuel cell applications as well. And the main reasons for us tackling our own membrane development program was because the cost structure of both electrolyzers and fuel cells can be dominated by the cost of the membrane, and we wanted to put a lot of effort into that to make sure that we could achieve a significant shift to the cost base of both of those systems. So
to bring the cost down or shift the cost, usually there's major points that are important. What would that be?
Okay, well, we're often trying to balance the 3 points of a triangle. There's cost, durability, and performance, and it's easy to optimize any one or even two of those, but doing all three together is the difficult bit. So what we've tried to do is make sure that the membrane material, the ingredients to the membrane material are low cost. So we use hydrocarbons rather than fluorocarbons, and they're about an order of magnitude lower in cost. And we've also worked very hard to make sure that we can achieve performance that in the early days matched the incumbent membrane technology, and more recently exceeds that performance level. And running along in parallel, we've been doing a huge amount of work on durability. And I can't emphasize how much time and equipment is required to do justice to a longevity program for new membranes and MEAs.
So ITM has done so much work on developing those membranes without wanting to really get in the technical side. I kind of enjoy it. So if we look into the DEO requirements for fuel cell, they usually require about 1 watt per centimeter square. Where do your membranes stand in that scale?
Sure. Okay, well, in fuel cell applications, one of the most important metrics, along with cost and durability, is the power density. And what that essentially means is how much power you can squeeze per unit area. And it's one of the most sensitive factors to reducing the cost of fuel cells, because if you can achieve more power per unit area. You need less stack. So you can reduce the size and volume of the stack as well as reducing the cost. The industry, the automotive industry, are targeting around 1 watt per square centimeter, and at the moment we're more than double that. there is a lot of work involved in taking what are results from a laboratory and making them effective in a fully scaled up system. And that's a process that we're involved in now with others.
Before I come on to the manufacturing portion of those membranes, I just want to remind the public that this is a public forum and you're welcome to ask any questions. Just raise your hand and I'll come down with a microphone. So ITM Power has some units on display, most of which are electrolysis, since this is what you're focusing on. But when we did our pre-talk, you were telling me that your focus is not manufacturing in the long run. You're kind of looking into partners to bring those units into full production. Yeah,
I think there's a differentiation for us between the fuel cell applications and the electrolyzer applications. We have developed fully integrated and CE marked electrolyzer products ranging from small scale hydrogen generators all the way up to hydrogen refueling stations and power to gas stations. The manufacturing strategy there has been to develop modules so that we can very efficiently, through manufacturing partnerships, accelerate our production to match demand without having to spend a lot of money in advance on extra factories and so on and so forth. So a lot of the designs of both the stacks and the balance of plant are sympathetic to a rapid scale up. On the fuel cell side, we don't intend to build fuel cell products at all. We plan to be a supplier of a membrane or a catalyst coated membrane as a key component into systems that other people have developed. There's been a lot of money spent in the fuel cell industry developing flow fields, cells and stacks and all of that balance of plant, and we don't want to re-spend the same money. We would rather work in partnership with other people and focus on the bit where we feel we can offer a real advantage, which is the membrane.
So we invite any possible partner that would like to produce some stack to come and see your booth, which is just behind us. We've talked a lot this week about the power to gas initiative and refueling stations here in Germany. But since ITM is from UK, maybe you can fill us in on what activities is going on in the UK on the refueling side of hydrogen.
Sure. Okay. Well, I'll do that, and I'll try and link it back to the membrane material in particular, because I think there are some characteristics of the membrane that do play into how the refueling stations are rolled out. But in the UK, there's a hydrogen mobility initiative similar to the one in Germany. And what it's trying to do is understand and quantify the appetite for fuel cell vehicles in the UK and what refueling infrastructure is necessary to support them. And on top of that, there is attention being given to where the hydrogen comes from and what the carbon footprint of that hydrogen looks like. The plans so far involve an initial rollout of 65 stations from 2000 and 2015. They'll be relatively small, about 80 kilograms of delivered hydrogen per day, and they will then, beyond that initial seeding, they will step out in tandem with the rollout of the hydrogen vehicles.
And ITM Power is quite involved in those 65 refueling station initiative, aren't you?
Well, we are one of the founding members of the UK Hydrogen Mobility Scheme, and we are one of the infrastructure providers in there, alongside Air Liquide, BOC Linde. But we are the only electrolyzer company, and one of the important decisions that the UK government have made, and in fact the same is true in Germany, is that 50% of the hydrogen delivered in that initial refueling infrastructure needs to be green, so it needs to have a very low carbon footprint. And for us, that means it's hydrogen generated by electrolysis, where the input power comes from renewables.
Yeah, and it's kind of an important point that a lot of people in the industry, we usually don't want to discuss it or touch it. It's a bit the taboo of the fuel cell and hydrogen industry, in the sense that yeah, fuel cell are zero-emission vehicles or zero-emission generating units. However, depending where the hydrogen comes from, that's not always true, in the sense that it can be a quite heavy carbon footprint depending on how it's going. And I think it's a great initiative from both Germany and the UK that they said this electrolysis, this hydrogen has to come from a zero-emission production facility, and that's where your membrane kind of comes in, because well, your great electrolysis, you have one of the biggest system. I wouldn't say the biggest because there's been some great news released this week. Can you tell us a little bit of one of your biggest projects you've done lately?
Yeah, okay, well, we recently made an agreement with the Tuga group of utilities that are based in Germany, and we're providing a PEM electrolyzer that's about 1/3 of a megawatt to provide a mechanism for sinking excess renewable power, converting it into hydrogen and putting it into the natural gas network. And what's important about that project and similar projects is that to be effective as a flexible electrical load, the electrolyzer needs to be able to switch on and off very rapidly. And the various electrolyzer technologies have different pros and cons when it comes to doing that. What I would say is that PEM electrolysis, such as that we use, is able to switch on very rapidly in under a second, and that means that it offers a great deal of flexibility for a utility company that's trying to make very rapid changes to the load that's being presented to their electricity network. So it comes right back to the membrane, and there are some very specific properties that we would seek to enhance when we're using the membrane for electrolysis and when we're using that membrane for fuel cells.
And I believe you're continuing your research or your development on even a faster reaction of your electrolyzer to be able to really turn them on and off on the desired utilities.
That's right. There are a series of payment structures that exist on in the UK. There's similar in Germany. And if you can provide an electrical load of a large scale, so 1 to 3 megawatts, and you can offer the ability to switch on and off in under 2 seconds, you can get a payment for that. So if at any point the utility company wants to turn you off, they can send you a signal, and you need to guarantee that you'll be able to turn off in less than 2 seconds. They may never ask you to do it, but if you're available to do it, then you can achieve some payments for that.
And would your unit be able to do that at this time?
Absolutely, yeah. That's it's part of the speed of the electrochemical process within the stack itself, and also the response characteristics of the power electronics. And we've worked very closely with AEG on how to do that.
You were mentioning earlier that part of the H2 mobility project in the UK, they're trying to feel if there's a demand or for hydrogen and whether people are ready to adopt fuel cell electric vehicles. On a personal note, do you think there is an appetite for a fuel cell electric vehicle in the UK?
I think so, absolutely. The UK Mobility Coalition has done a lot of work to try and engage with potential customers and understand what their views are, who's prepared to pay a premium for those early fuel cell vehicles, and get some quantification for that. One of the factors that was most sensitive actually in appetite was proximity of refueling stations. And if you only had one refueling station available to you in your local area, the demand was much lower. Having two made a huge difference. So that was one of the important inputs to the modelling process that determined strategically where to locate those early refueling stations to maximise uptake. But all of the automotive OEMs that are rolling out cars are standing by their statements that they will be rolling them out from 2015. There are some very significant efforts underway to reduce the cost of those vehicles. The fuel cell stack is one of the most expensive elements, and again, increasing power density by membrane improvements and catalyst improvements helps to make a big impact on that overall cost structure. And
your technology has some of the best power density out there, so it would overall bring the cost down for those vehicles.
Yeah, and I don't want to go too technical, but I'm quite happy to talk about some of the chemical structures and how we manipulate those to achieve that. Maybe I'll do a quick overview, and then if anybody wants any more information, they can ask me. But I think importantly, having a material that you can modify the properties of to suit different applications is very important. And the way we do that is we, instead of buying a standard film of membrane material, we buy in liquid materials that we can mix to a particular formula and then polymerize a sheet of material in one process. And so that means that we have actually a full suite of materials, because we can modify the ratio of the ingredients. For example, if you wanted to use the membrane in a high pressure electrolyzer, you can add more cross-linking agent or more of the mechanical components to have a tougher material that's able to withstand the mechanical forces that are placed on it. Whereas if we're looking at a fuel cell, we would be looking to maximize the ionic conductivity to try and squeeze as much power out of it as possible. And if you have the chemistry that allows you to play those tunes and the understanding of how the different ingredients interplay with one another, you can actually start to do some really effective membrane engineering to develop the material in a particular direction to give you the properties that you need. So it's a very flexible structure, and fuel cells and electrolyzers are our first applications for it, but I can see many others as well, in fact.
Other possible uses. And ITM Power has one of their electrolyzers or refueling station on demo here at the Wright Park, which is at the end of the hall, or this way. It's been in operation all week.
Yeah, we've been here actually a couple of weeks before the show started, going through all of the compliance work and getting the equipment set up and operational. But we have been doing refueling demonstrations 4 times a day. So if anybody does want to have a look at the equipment and look inside it, I think what time we are, but there's certainly one at 2 o'clock and 4 o'clock today. So anybody wants to come and have a look, they're more than welcome to see how we're generating the hydrogen on site, how we compress it, how we store it, and what the refueling process itself is like.
And those stations could also be used for fleet services.
Yeah, we've undertaken a number of field trials with this piece of equipment. It's a transportable refueling station, and so we have done, I think it's 22 different trials with customers like DHL, Marks and Spencer's, UPS in the UK and Germany. And one model that works very well is the return to base model. So a fleet of vehicles like a delivery fleet, or manual handling vehicles, materials handling vehicles like forklift trucks, that always return to the same place to refuel, is a very interesting and attractive first market. And one of the most significant trials within the 22 that we undertook was with Marks and Spencer's, where we were looking at providing an alternative to battery-powered forklift trucks. The fuel cell versions that we were able to supply, along with our refueler, had a number of advantages in that they could be refueled in 90 seconds rather than 6 hours or whatever it takes. And importantly, the forklift truck will give full power throughout the whole shift, whereas with battery vehicles, they tend to droop a little bit throughout the day. I know the feeling.
And you were saying when I met with you earlier yesterday that some of the smaller units you have are kind of allowing a possible customer to trial the technology, to really feel comfortable with it prior to buying a full refueling station, like for those fleet services?
That's right, and it is quite a challenge really for a relative newcomer to the industry to convince people that your technology is reliable and robust and all of those things, and safe. So we have 2 main routes to achieving that level of confidence. One is to do a field trial first, so we can come to some sort of a great agreement where they can essentially try before they buy, and the second. The second route is for them to purchase a smaller system, and we can give them the freedom to operate that system in a variety of different ways. So they can essentially pressure test it, make sure it does what it needs to do, and they use that as a due diligence process. So often some of the smaller electrolyzers that are on the stand today would be used for that purpose.
Well, Dr. Bourne, I totally appreciate your time with me today, and I'll invite the rest of the floor if you have more further question on the subject, because I know Dr. Bourne can get quite technical on some of those membranes and give you the ins and out. I'll invite you to come and join them back at their booth, which is right behind us on B60, and I'm sure they'll be happy to give you more information. So thank you very much for your time, Dr. Bourne.
Thank you.
Hope to see you next year.